class, this is Ms. Cook. Let's go ahead and talk about solving SSA or side-side angle triangles. So when you're given two sides and the angle opposite one of those two sides, you can use the law of sines in order to set up and solve that triangle. And that's because since I'm given a side and an angle opposite, I can say use that ratio of A over sine A equals B over sine B equals C over sine C. Okay, but this is known as the ambiguous case. And this is because we are using the sine function. And the sine function is positive in both quadrant 1 and quadrant 2. And why that's important is because my angles, we're just going to call angle theta, can lie anywhere between 0 and 180 degrees because they're all parts of a triangle. So that puts us in Q1 and Q2. Well, sine is positive in Q1 and Q2. Okay, so sometimes you will have one angle that'll work, and that will be a quadrant 1 angle. Sometimes you will have that second quadrant 2 angle, and that will be an obtuse angle, and you'll have an obtuse triangle, and that angle will work. Sometimes we'll find that that second angle is too big, and it just doesn't work for our triangle. And sometimes the ratios don't quite work out, and you won't have any triangle that'll work. Okay, so let's start with this first example. This first example where we have a triangle with one solution, okay? So I want to solve the triangle with angle A being 30 degrees, side A being 81 degrees, and side B being 62 degrees. So first off, we can draw us a picture just to orient our brains a little bit. All right, just to get us started. We know this one, I give it away, there's only one solution, so I'm just going to let that be what it is and just draw one triangle. Okay, so I know angle A is 43, side A is 81. Angle B and C are unknown, but I do know side B is 62, and that's all I have. And I need to find angle B, angle C, and side little c. Okay, so since I'm given an angle and its opposite side, I can start with the law of sines. Now I can't use the law of sines to find anything involving C, side C or angle C, because I don't know either of those. But I do know side B, so I can start with that. So little a over sine of angle A, which is 43, equals 62, which is angle or side B, and the sine of angle B. Okay, so now with some cross multiplication and division, all right, we're going to get 81 times sine B equals 62 times sine of 43. Okay, and then so that means sine of angle B equals 62 sine of 43 over 81. Okay, so we can plug that in our calculators. We're going to have to round, okay, to see what we get here. So 62 sine of 43 divided by 81. And again, I am making sure that my calculator says degrees still right here. You might have had to change it for a homework problem. All right, so that ratio ends up being 0.522. That's enough for me. Those 3 decimal places, I'll just use those. Where you will have no solution is here, and you will have no solution when you get a number that's bigger than 1, because sine is only between -1 and 1. So you may get a value here that's bigger than 1. In that case, you will have no solution. Okay? So in this case, I get, though, sine B is approximately 0.522. And so now I need to apply an inverse function. So angle B is going to be sine inverse of 0.522. All right? And I know I can do this because 0.522 is between 0, or negative 1 and 1. Okay? So that's good to go. So second, sine inverse 0.522. All right, and that should be enough decimal places to get you where you need to go. Okay, and I get an angle of 31.47 degrees approximately. Oh, 41, sorry. Okay, but this is only my quadrant 1 angle. I have to, since sine is positive in both quadrant 1 and quadrant 2, and quadrant 2 is within that 180 degree range that I can have an angle of my triangle, I need to find that quadrant 2 angle. So I'm going to call that B1 for quadrant 1. B2 is going to be 180 minus 41.47. And that comes from, I've given you a couple of charts that'll have some of those relationships. You start with the quadrant 1 angle. I believe this was in the last chapter. You have a table of how to find the other quadrantal angles. Okay? And here is where we will see that we only have one triangle. So 180 minus 31.47. I know I need to change that to a 31, is 148.53. Sorry, let me change that to a 3. Okay, and I get, again, excuse me for that, 148.53. Okay? All right. So that's a really large obtuse angle. Will that fit in my triangle given angle A? Well, no. This one doesn't work because angle A is already 43 degrees. So A plus B is already going to be way greater than 180 degrees. So 43 plus 148.53 is 191.53. This is too large. All right, so I only have one angle choice for side B, or angle B, and that's 31.47. So B is 31.47. All right, so now the rest of it comes fairly straightforward. I'm given A and B, angle A and B, and now I can easily find angle C. So angle C equals 180 minus angle A and minus angle B. So 43 and minus 31.47. Okay, 180 minus 43 minus 31.47. Okay, so that ends up being 105.53 degrees. All right, so there's angle C. So now I just need to use or find side C. Once again, now that I have angle C, I'm going to call on the law of sines. So I'm going to use, you can use side B and angle B, but since angle B was an unknown, I feel a little bit uncomfortable using that just in case I may have done something wrong at finding side B, or angle B rather. So let's use angle A and side A since that was a given. So 81, excuse me, over sine of 43 equals little c over sine of 105.53 degrees. Okay, and we have done this before in the last previous examples, where now this is a multiplication problem where I can just multiply both sides by sine of 105.3 or 105.53. All right, so angle C is sine of 105.53 times 81 over sine of 43. Okay, so once again, I can use my handy calculator. Clear some of that. So sine of 105.53. Yep. All right, and then, okay, and then times 81 divided by sine of 43. All right, and I get that side, little c, should be 114.43. I'll just keep with the 2 decimal places. All right. And with that, my triangle is solved. So I'm going to box in all my answers so y'all see exactly what we found. Y'all have a wonderful day.